Alright, welcome to my video. I apologize if this is going to be a little fast. I've tried to do this 4 times now, and each time it's cut me off saying I don't have enough storage to make this video. So I apologize, but I'm going to make this fast. Alright, so this is exam 4, last exam. Question 1. I said that the first one is constitutive, second one is constitutive also. D is non-inducible. No, sorry, C is non-inducible. D is constitutive, and E is inducible. The reason I said this is because 1, A has a lac-L operon. Lac-L operon that is non-functional. If we look back here really quick, though, the lac-LS is dominant to lac-L plus, which is dominant to lac-L minus. That's going to come in handy for B. And also for D and E. For B, though, I can't remember why the lac-LS is undesirable. So I said it's constitutive because it's not normal. But it actually could be inducible. But I can't remember. And I wasn't going to look at my notes because that would be cheating. Anyway, C is going to be non-inducible because our lac-P and our lac-OC are non-functional, so we don't have a binding site for the repressor, nor do we have binding site for the sigma factor or RNA polymerase. For part D, I'm going to say the same thing, constitutive because of this IS, or the LS, same as B, also constitutive. For part E, because L plus is dominant to L minus, I'm going to say it's inducible because it's all functioning. So we don't have to worry about that. Question 2 wants us to draw out the map. First, what you got to do is decide, okay, because our primer is going to start here, it'll go from left to right. And we have our template strand right here, and then this is the complementary strand, G to C, T to A. You can see that. Because in the instructions we start with GTP and then end at CTP. I'm going to start right here at the G and work my way to the 3' end. So we can say GCA, GCA, TAA, TAA, and so on and so forth. So that's how you do question 2. And then also make sure your negative end is on top and your positive end on spot is your negative end is on top, your positive end is on bottom, because the DNA are going to migrate down to the positive region because they're negatively charged. Alright, so question 3, we're going to need the wobble rules right here. So basically, if your tRNA has any of these, or no, depending on which of these your tRNA has on its wobble anticodon, the wobble base, will decide what mRNA nucleotide you used. Okay, so if we have a G, then we could add on a gtRNA anticodon. We could add on a C and a U at the wobble spot. If we have a C, then we can add a G, and so on and so forth. And then vice versa. If we have a U, we can add a G, or a C can also be a G, and so on and so forth. And so that's what I did here. I made a mistake, though, and I hope that I can get partial credit for noticing now. I said that the tRNA does indeed start on, or does indeed have its wobble nucleotide on the 5' end. Unfortunately, I misinterpreted it, and this is really the mRNA. This is really the mRNA. And so these are going to be my tRNAs, and so my wobble is off, because I'm supposed to give all the possible tRNAs, and then same thing for here. These are my mRNAs. This is my tRNA, but I didn't realize that, and so I didn't realize that the wobble molecule was going to happen right here. So that is incorrect, but that's how you do it. For question 4, just as mathematics, we can see that 20 amino acids are going to be at about 125 Daltons each. If we had 75 kilodaltons, we multiply 75,000 by, or we divide 75,000 by 125 to get about 600 amino acids, which is that information right up there. We multiply that by 3 because there's 3 nucleotides per amino acid, so we get 1800 nucleotides. Then it wants us to identify UTR. These are sites to help in termination of transcription. How many ATP molecules are there? Well, that's easy. For every tmRNA, it's going to use 1 ATP to charge it with an amino acid, and so you take the amount of amino acids and multiply it by 1. But then because we have 100 copies of our 600 gene, we multiply that by 100 to get 60,000. And then how many GTPs? Well, it's 2 per cycle, 2 to begin and 1 to stop. So you do 1 times the amino acids, multiply that by 50 because it happened 50 times, and then you add 3, 2 to start, 1 to end. So it's 60,003 GTP molecules are used. And you can see by this little chart, this is what's happening. So 2 to shift it, 2 and to link it, 2 to begin by putting the subunits on, and 1 to stop. And then that's it. So thanks for watching. Hope you have a great day. Good luck on your test.